then 0 plus pi k. Is everyone okay with why that's the same thing? You don't have to write it that way, but does everyone understand why you could get away with just doing 0 plus pi k or just pi k and get all of these? Because they're just pi away from what? Okay, so just mental note, sometimes the back of the book will look like that. It doesn't mean yours has to look like that. You can always do it this way. Always find the values from 0 to 360 and just tack on a plus 2 pi k. But just be able to recognize if you're multiple choice or if you're in the back of the book that they may combine two together if they're pi apart. Does that make sense? Okay. It's pretty awful. I didn't start you off on the last one. It wasn't too bad.
Or we should feel like examples.
Yeah, more examples. In fact, today I think I have 3, maybe 4 slides, and then you'll have some homework time. And you have, I think, 12 more problems or 6 more problems. What did I tell you? 6 more problems. So there's a few to add to your homework, but
Yes, I'm confused with them.
okay, you should have some time to ask questions. What is the problem here?
Oh!
Got red, 3.
They're not the same, right? Cotangent, cosecant, they're not the same thing. Bigger problem is I can't just use a Pythagorean identity because they're not squared. So
Square them.
okay, you can just square both sides of an equation. There is one danger in it. When you square both sides of an equation, you remember when you were solving square roots? Bless you. You sometimes got extraneous solutions. Y'all remember that word from Alpha 2? A fancy word for extras. You remember how you had to check your answers and sometimes one wouldn't work? You got those both on square root equations and on rational equations when you had a denominator because you could get some undefined answers. So anytime you square both sides of the equation, because it gets rid of any negative values, you could get extra answers. That's not a real big deal. We'll just need to check our answer when we're done. But know that if you square both sides of an equation, if you ever do that, then we then have to check our answer. It's no longer just a matter of check it to make sure I did it right. It's check it because there could be extra answers.
Well, let's do something else.
I think squaring is a good idea.
Alright, let's square it.
If I square both sides, what do I have to do on the left?
No. Multiply it out.
Foil. Or if you, but make sure you don't call it cotangent squared minus 3, right? That is not correct. Does everyone agree with that? It's not cotangent squared plus 3, not cotangent squared minus 3. You actually have to multiply that out. I did cotangent squared. Are y'all okay with me doing that all at once? Looks pretty difficult. Maybe it is. Do I now have an identity for cosecant squared that I could change it into a cotangent? What is the identity?
1 plus cotangent.
1 plus cotangent squared is cosecant squared. It looks horrible, but now that you see this step, isn't that bad? Why not? What happens? It's really nice.
Both squares go away.
The cotangent squares end up canceling when you subtract those from both sides. So that makes this a much easier equation, doesn't it? 1 over 3. So I get -2 radical 3 cotangent x plus 2 equals 0. Now I only have one trig function involved, so I just get it by itself. Any questions? When is cotangent positive? First and third. Sorry, I should have that stuff. Y'all are very forgiving. Adjacent over opposite. I think. So those are 60-degree angles. So what would x be? And since we are x, it says 0 to 2 pi, right? So what would that be in radians?
Right over 3 and
Does everyone know where you got 5 pi over 3 and 4 pi over 3? So this is 3 pi over 3.
I get it.
Plug those in and check and make sure they work. Right? Remember when we square both sides. Now, is it a good idea to do this all the time? Probably. But anytime you square both sides, you have to. So go back to the original, plug those two values in. I mean, hopefully they work, but just need to check. Cotangent of pi over 3. What is cotangent of pi over 3?
1 over 3.
1 over the square root of 3. 1 over the square root of 3 minus pi over 3. And what is cosecant of pi over 3? The picture didn't explain.
19. Hypotenuse over offset.
2 over radical 3.
Negative.
And since we are pi over 3 first quadrant, everything was positive on this one. It will change when we go to the other one. Any questions so far? Common denominator, if you multiply this by radical 3 on top and bottom. And if you have a calculator, by all means, pick it up and check it there. Radical 3 times radical 3 is 3. 1 minus 3 is negative 2. Is negative 2 over radical 3 the same as positive 2 over radical 3? So did it work? No. Now why did we get that error? Well, we pretended they were both positive, right? Because we squared them both. You see why you get that error when you square both sides? So be careful about that. Say that was not a real solution. We did everything right, but it didn't work because of the way we solved it. Okay, let's check 4 pi over 3. Those are both negative, but that's a positive 2 this time. And so on 4 pi over 3, we get negative, this is positive, this negative, so 1 over radical 3 minus radical 3, this time it's negative 2 over radical 3. And so the only difference here is that this is negative, which works out good, doesn't it? Because the left is negative.
Yeah.
Because we've already done 1 over radical 3 minus radical 3. We got negative 2 over radical 3. So the second one works. It is very common when you work a problem by squaring both sides that you get an extra answer that way. So be careful about that. Start it in your notes. If you square both sides, it's a perfectly good way to solve an equation. It just will give you extra answers. Does everyone, again, again, see why you get extra answers? Because of the negatives going away. You may see me work a problem one way, and you may work it a different way. Is that okay? Yes. There are, just like trig identities, there are going to be a lot of different approaches you could take on the same problem. So just mental note, if you work it different than I do, that's fine. There are two approaches on this one. One of them is just straight using your unit circle and using it well. The other one is actually going through the process of getting that same trig function there using an identity or something and solving. I want you to see both. First option is to just say, okay, even though this isn't a normal way to solve it, can I think about that question? When is anybody the cotangent? Well, think about your unit circle. When is the only time opposite over adjacent and adjacent over opposite are the same?
In quadrant 1, radical 2 over 2.
Our force? In fact, all of them, right? All of the 45-degree angles with opposite and adjacent sides are the same value, even if they're positive, negative, and negative, positive. It really doesn't matter as long as it's the same, right? Negative divide out or whatever it may be. So the answer to that is pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And then since it doesn't say, it looks like they're wanting us to do, since theta. Since it doesn't have an interval, I suppose we could do all of them. Of course, we could do 45, 135, 215, 225, and 315. And then plus 360k on the end of all of them. Or plus 90k. You don't have to do it that way. It would work either way. Why does that work? They just are 95 degrees. Now, is that going to work for every, just the 45s? But, if you see something like that, you can shortcut your work. So that's one option for solving that equation. Of course, I think it's the best option, except when you don't see it. Right? There are going to be times you still see that happen. So, what's the other option? What do you try to get one common trig function, is that what you mean? Okay, how? Okay, either go to sines and cosines, or you could rewrite cotangent as 1 over tangent and get a common denominator. So either way, which one is our favorite?
Sine over cosine.
Okay. Sine of theta over cosine theta minus cosine theta over sine theta. So I get sine squared of theta minus cosine squared of theta over sine theta cosine theta. But if this fraction is going to equal 0, what would have to be 0?
The numerator.
The numerator. In fact, the denominator being 0 would be a problem, right? Because we can't have a 0 denominator. So I'm going to look at when is sine squared of theta minus cosine squared of theta equals 0. I can change sine into cosine. I can put that up. Where you have a hard time seeing it. Sine squared is what?
1 minus cosine
1
squared.
minus cosine squared. Does that make sense? What would make it equal 0? Good question.
It's essentially multiplying the denominator by 0.
Yeah, you could cross multiply if you think about that.
Okay.
So, for a fraction to be 0, the only way that can happen is for the top to be 0.
So it doesn't matter.
So we're going to ignore the bottom for a moment. It's not gone. We'll have to make sure our answers don't make the bottom 0. But how did y'all solve rational equations last year? Like one's a fraction.
Yeah.
Just multiply out the fractions. Divide out the fractions.
Can you get like the tops equal? But okay, someone give me a fraction that equals 0.
0 over 4.
Okay, give me another.
0 over 3.
Is the top always has to be 0, right? So if a fraction's going to equal 0, the top has to be 0.
So keep going. Please.
Square root both sides. When I square root, I get a what? You do that too. What else? Plus or minus. Do not forget your plus or minus. Simplifying this, you agree I get 1 over the square root of 2. Draw a picture. All 4 quadrants. Does everyone agree? All 4 quadrants, since we're plus and minus? Yes. How far? Negative cosine squared minus cosine squared. There's 2 of them. It is. Now, are you accidentally sometimes going to do it the super long way when there was a super short way? Yeah, it's going to happen. It's okay. Adjacent over hypotenuse, what is a 1 radical 2 triangle? 45, right? In all 4 quadrants, since we're plus or minus, and so we end up with the answer we had earlier, which we hoped we would. That would be good if they were the same answer both ways. Questions about that one? What would I do on this next one?
I don't think there's.
Good.
Identity.
What identity?
What's cotangent equals?
1 plus cotangent squared equals, or cosecant squared. Why would you choose that?
Cotangent squared.
We have a cosecant squared, we have a cotangent. We would really like those to all be the same frequency. It would be nice, because then we might have a chance at factoring or something like that. I'm going to rearrange. Some of you might do this without rearranging, but I would rearrange.
Cotangent minus 1. Cotangent minus 1.
Good. Cotangent minus 1, cotangent minus 1. Factors. Factors of 1 that add to give you 2. Minus 1. Am I going too fast? So cotangent of theta equals 1. When does cotangent equal 1? First of all, what quadrant is cotangent positive in? First and third. Right?
Do we ever have to do multiplicities again? Like, why do we even have to do this?
I told you on a graph whether a 0 was going to touch across. There's some times that comes in handy, being able to know that. Are you ever going to just be asked about it again? Probably not, but will it ever help you that you know it? Probably. Cotangent of theta equals 1 at 45 and 45 and 225, and then since this doesn't give me an interval, I'm going to keep going with that. You could, of course, do 45 plus 360k and 225 plus 360k. I love it. I would count. Or you could do 45 plus 180. Again, if you don't see that, that's not a problem. I will not count off. Right at the top of your homework. Right.
If we have it once, is it alright?
Yeah. Okay. These are already the same trick function. This one doesn't factor. We did one like this yesterday with quadratic formula, right? This doesn't factor, right? 3, 1, oh, subtract 2. So we did one like this yesterday with the quadratic formula, which was great and all. I'm kind of over that, would rather not do it again. So what is another option for solving this? I know obviously this quadratic formula is calculator. Graph, so get your calculators out. This is my preferred method to solve a problem like this. Now, again, quadratic formula exists. It was cool. You saw it. Fun times. But real world scenario, probably if cosine is involved, you're going to get a calculator. So, go to y equals. First of all, how do you type in sine squared?
Sine of x squared.
Good. Sine of x in parentheses squared. Oops. You could probably get away without the parentheses, but. Oops.
Right. Do we write sine of x squared or?
Sine of x all squared.
Oh, so it can't be sine of x squared.
Right. And then minus 1. Yep, in y1. So this is what I showed you at the end of class yesterday, the solving graphically by finding intersections. Do you remember that? So we're doing another one like that. I am going to put my calculator in radians since it's x, not theta. Just read the book. I think this book does a little better job of telling you which one to do. I'm going to set my window from 0 to 2 pi on my x values. Why would I do that? Yeah, now I want all solutions, but why is 0 to 2 pi a good start? It's repetitive after that, right? So after 0 to 2 pi, I can put plus 2 pi k and call it a day and move on with life, right? So, and my y min and max, I'm looking for it to cross the x-axis, right? So I'm going to do negative 1 to 1. Whoops. I'm going to actually do negative 1 to 1. Because I'm looking for where it crosses the x-axis, since I'm looking for it to equal 0. I did put 0 in y2 so that I could use the intersection button. Or if you don't want to put 0 in y2, you can use the zeros button. Does everyone know what button I'm talking about with the zeros button? So if you go to, does everyone see the answers? There are 4 of them, aren't there? So if you go to second trace, you can either go to number 2 to use the zeros button. To do that, you have to go to the left and right of each 0. To me, it takes a little longer, and I'm lazy. So I like the intersection button better because I can push enter 3 times and move on. So intersection, push enter 3 times. It'll give you the first one. or whatever one you're closest to. 3.591. Make sure you always round to 3 decimal places. We're training for AP Calculus. 3 decimal places, that's how much the AP exam expects you to have. It's 3. So do 3. Someone write that down for me. Actually, I've got my handy dandy. Well, they're radians. Why did I use an approximation symbol? Because I rounded. So I'm going to go find another one. Second trace 5. I've got to move over to a different one. You notice there are 4 of them that I need to find. So make sure you find all 4. 2.267. Now, normally I would write these all in the same line, but since I'm going to have to do a plus 2 pi k on it, I'm just going to put them all in different places so I don't have to rewrite them later. Are you okay if I don't show my calculator when I find the other 2 intersections? Just make sure you can, though. Do it with me. 0.875. And how are we doing with a calculator? Any questions about? Okay, come see. Are you using the intersection button or the zeros button?
The intersection.
Do you have 0 and Y2?
No.
What are you intersecting?
Yeah.
Do you have 0 and Y2? If you want to use the intersection button, you have to put 0 and Y2 because you have to have something to intersect. If you don't want to do that, you can use the zeros button. To me, I would rather take the extra time to type 0 and Y2 because then I get to click 3 times easy. Where if you do the zeros button, you have to go to the left. Have y'all used the zeros button before?
Yeah.
You have to go to the left of the 0 and push enter, and then to the right of the 0 and push enter, and then push enter again. To me, it's a little bit more tedious. I'll show you that button too, though. 5.834. That, and then put 0 and Y2. Because you want to intersect something. You want to know when it intersects 0. To use the intersection button, you have to have both in. Okay, everyone watching really quick. If you do not put 0 in Y2, listen. If you do not put 0 in Y2, when you try the intersection button, it will never go past second curve. Why not? Because you don't have a second curve. So your calculator's like, how am I going to intersect? But if you want to do that without putting 0 in Y2, you would go to second trace 0. The only difference is then when you find a 0, you have to go to the left of that 0 and to the right of that 0 and then push enter. It makes me sound really lazy, but to me that's an extra calculator step, you know what I mean, where I have to go left and right, and again, I'm lazy. I'm a math person. We're lazy, so the intersection button's a little quicker, so I prefer it. Okay, on all 4 of those answers, I'm going to do plus 2 pi k. On a decimal, I am rarely going to look for a shortcut to write this because most likely it's not going to work out nicely on a decimal where they're exactly 45 apart or something. Hey, any questions about that one? Much easier than the quadratic formula, right? This was the one we did yesterday with quadratic formula. Since we just did one just like it, if y'all are okay, I'm just going to skip it. And this is your addition to your homework right here. They are both due Thursday. You have, what do we get out here? 10 after on app days? Yeah, we've got 5 after. So you have a little over 5 minutes. You can ask me some questions in that time if you have any. what is that? 6 problems added. So not a whole lot more problems, just a few more.
You do 11 on part.
Yeah. What is it?